everyone, my name is Araya Shah and today I will present an experiment called milk fireworks. It's technically fireworks but without the noise and the smoke. So what I have here is some different milks: almond, oat and cow milk. I also have some food colors. I have some dishwashing soap, a wipe to wipe my hands, and a few cotton buds. So I have my cow's milk, right? I have my cow's milk, and I will pour it into this plate. Next, I'm going to take my soap and my cotton buds. So now what I'm going to do here is take a cotton bud and put it into the soap. Now, I'm going to take my food colors and drop them into the milk. And I have my food colors and I'm going to drop them into my milk. One more. Now I'll do blue. Now I'm going to do yellow. And finally red. Now I will take my Q-tip and watch what happens. Now I will try with oat milk and almond milk. Now I will take my cotton bud again and put them into the soap. Now I'm going to do the colors again. Now I will do yellow. lastly glue. Now I will take my cotton buds and then the colors start moving away.
Wow.
So the explanation for this, there are two reasons. Number one is surface tension. Surface tension.
Okay.
So, all the molecules in a liquid hold hands with each other. On the top layer, they hold hands even tighter. So, when they hold hands even tighter, it creates a tight film on top called surface tension. So, since soap is a surfactant, which means it breaks the surface tension. So, when you take the cotton bud dipped in soap and you put it into the milk, you see the colors dancing around. But it's actually the milk's molecules, part water, part fats, moving around. So, the second reason is soap itself. So, soap is made of chains, of particles, which one end of the soap chain loves fats and the other end loves water. So, since milk has both fats and water, we take the cotton bud dipped in soap and the colors start moving away. So there are different consistencies of fat in each of the milks. Now I have a white solid here. I'm going to do the exact same thing. Put the food coloring. Green. And blue. So now I'm going to dip the soap into this and nothing happens. The reason as to why this happens is because soap is surface tension is a property of liquids and not solids. So even if we dip it in the soap and put it into the place where the food coloring is, none of the fireworks happen.
None of the fireworks happen.
Yeah, none of the fireworks happen. That was my presentation for today, and I have a question for you. Where do we see surface tension in nature? Where do we see surface tension in nature?
In nature?
Yes.
Lakes?
Yes, but something happening to the lakes. Sort of like when little animals and insects are walking on water. So that was my presentation for today. Thank you. And if there's any questions, you can ask.
It was a very nice presentation.
Thank you.
My question to you is, why did you decide to use 3 different milks?
Because I wanted to see which different reactions come in the different kinds of milk.
So your variables.
Mm-hmm.
Okay. What did you change?
I changed the types of milk and
what did you keep the same in all three?
I kept the same, that they were all milks.
No, what did you keep the same?
Oh yeah, I kept the same, that I added food coloring in each one.
Do you know if it would be different if you use a different soap? Do you think if you have used a different soap, it would?
Yes, I think it would be different, because this is dishwashing soap, there's hand washing soap, there's body washing soap, all sorts of soap.
Yeah.
So
there
that
would be
would
different fireworks?
yeah, maybe. But the different milks definitely make the different fireworks.
Who do you think could use this in real life?
In real life, maybe the world's best scientist. Or something like that.
You want to be a scientist?
Yeah, I want to be anything I can possibly be.
But these color patterns, can we use it somewhere in our houses or somewhere?
The place of noble life.
Well done. Very good.
Yeah.
Very, very nice. I'm so happy. You know that all the layers of the earth. Yeah?
Yeah.
How is the shape of the earth?
The earth is round. The earth is round and very big.
Very big. Oh,
Yeah.
wow. Very good.
Yeah.
My name is Onish. Today I'm going to explain to you about growing plants. Now I'm going to explain to you the life cycle of a bean plant. The seed goes through the process of seed germination, after which it becomes a seedling. After a few days, the seedling continues to grow, then red or white flowers come out. After a few days, the red or white flowers remove pods of beans, which we can pick and eat. And the pods of beans remove fruit. And then the fruit throws the seeds onto the ground, and the plants die and new plants grow. Now, I'm going to explain to you what is the process of seed germination. First, the seed is planted. After 2 or 3 days, the shoot emerges. After a few days, the stem comes out, then the leaves come out. The leaves continue to grow and the stem increases, and that is the seedling. The seedling continues to grow, and then the leaves become bigger, more leaves come out, and stem increases. And then after a few days, red or white flowers come out, and the red or white flowers remove pods of beans, which we can pick and eat, and the pods of beans remove fruit, and the fruit throws the seeds onto the ground and the plants die. What is photosynthesis? Photosynthesis is how plants make their own food. They use air, sunlight, water to make their food. They absorb carbon dioxide and release oxygen. I've already explained to you the bean plant life cycle. Now I'm going to explain to you the functions of the parts of the plant. The seed grows into a new plant. The fruit throws seeds onto the ground. The flower helps plant reproduce. The leaf makes food from sunlight. The stem transports water and supports plant. Roots helps plant absorbs water and anchors plant. Now I'm going to explain to you what is compost. Compost is peels of vegetables, dry fruits, peels of fruits or dry leaves or dry flowers. Now I'm going to explain to you my chart. I brought 4 pots. I labeled them plant B, plant A, plant B, plant C. And then I put red soil and fertilizer in the 3 pots. But only in plant B I put only garden soil in plant B, and the rest 3 I put red soil and fertilizer. Then I made a hole. Then I put 5 seeds into each pot, and then I covered them. I put water in the seeds, and then after a few days the shoot started to grow. Then roots came out, then stem came out, then leaves came out, then it was a seedling. We added compost to the plant, and then plant B removed some pods or beans which we can pick and eat. Now then it's going to remove pods. Now it's going to remove fruit. Then plant A, plant C have died because of lack of water and lack of sunlight. Plant D is growing as a seedling. I'm done. Thank you. You can ask me any question.
What is the first thing which is growing when you put seed?
The shoot.
Shoot.
Yeah.
Can you explain to me why the other ones died? What do the plants need to survive?
The plants need to survive.
What do they need?
They need water and sunlight and air to grow. Yeah.
So why did this plant A die?
Because of lack of sunlight and lack of water and no air.
Keep this plant.
This plant, I kept it over there.
No, this plant.
This plant,
You have not given sunlight. So where
I've
did you keep it?
I've not given sunlight, so I kept it in my balcony.
In your balcony.
Yeah, there's a balcony which gives it lots of sunlight. But
So was it in sunlight or without sunlight?
yeah, that time it was in class,
Okay.
so that's why it didn't grow. It was dead. Because
Class.
yeah,
And then what about this?
plant C, it already died because of lack of water.
You did not water it? Did you water this plant?
Yeah, a bit.
Bit.
Yeah, and
What
no
about this? Did you
even
water it?
only a bit. Like these
What
2
about
plants,
this?
I put in this plant. I put 100 ml in this plant. These 2 plants 100 ml. These 2 plants 30 ml. 30.
30 ml.
Yeah.
So these 2 plants 30 ml and
Yeah.
these 2 plants 100 ml. Why did this one grow better?
This one grew better because there is enough sunlight for it and enough water for it and enough air for it.
So which soil it was?
This soil was garden soil.
And this one?
These 3 are red soil and fertilizer.
So, okay.
Thank you.
So what were you trying to show? Like what was the importance of this?
The importance of this, I was trying to show how my plants grew. How my plants grew
With
with everything like air, water, sunlight for it to grow. With that.
Good morning everyone. My name is Ivy Raul
Loudly.
Haria. Good morning everyone. My name is Arvi Rawal Haria from class 1D. My project is about growing plants. We see plants all around us. Plants are living things. They make our surrounding green and beautiful. For a plant to grow, it needs seed, soil and sunlight, water and air to grow. The growth of a seed into a young plant is called germination. There are 4 stages of germination. A seed, root appears, shoot appears, leaf appears. There are different parts of the plant: root, stem, bud, leaf, fruit and flower. The functions of the plant's part are: root. It holds the plant firmly in the soil. It absorbs water and minerals and stores food for the plant. Stem. It supports the plant and carries water, minerals and food to all the parts of the plant. Bud. It grows into a leaf or a flower. Leaf. It makes food for the plant. They take carbon dioxide and release oxygen into the air. Fruit. It contains seeds and protects the seed. Flower. It helps the plant have more seed. Plants have the characteristics of living things. They reproduce, they breathe, they grow, they feed. They die when their life cycle is complete. Plants are very important to us. They give us food, air, wood, flower, and shade. They also make our earth beautiful and healthy. We should love and take care of plants. Plants are by watering them from harm. I love planting seeds and take care of plants. Thank you.
Can you show them on the model, whatever? Where are the leaves?
The leaves are here.
Okay. What do the leaves do for the plant?
They make food for the plant.
Okay.
Where are the roots?
Here.
What do they do?
They hold the plant and absorb water and minerals and store food for the plant.
So why do the plants need to make food for themselves? What happens when there is no leaves?
The flower will die.
They die.
And what is stem doing?
It holds the plant.
Apart from holding the plant, what else stem do?
It gives water, minerals and food to all the parts of the plant.
Did anyone help you make this project?
Yes, my mom and dad.
And which part did you do on your own?
The coloring. Good morning everyone. My name is Parikshit Agraut. So now today I'm going to present a project about us and our sense organs. So let's get started. So this is my science box. Each one has 3 cards and this is my key to remove each card. Card A. This is my eye. I use it to see the world. Card B. My eye helps me see beautiful colors like a rainbow. Card C. They also warn me to not look at the horizon. It will hurt my eyes. Now we know about eye for sight. Let's get to the second. Card A. This is my ear. I use it to hear sounds.
Where is your ear?
Here. My ear let me listen sweet happy music. Card C. And they hear loud sirens, so I know a fire truck is coming. Now we know about ear for hearing. Now let's go to the second one. Nose for smell. Card A. This is my nose. I use it to smell things. Card B. I love to smell fresh, sweet flowers in the garden. Yuck! My nose also smells bad thing of garbage. So we have 2 holes in our nose. They are called nostrils. We have hair in our nose. They protect us from bacteria, viruses and dust. Now we know about nose to smell. Now let's go to the second one. Tongue to taste. Card A. This is my tongue. I use it to taste my food. Card B. Yum! I can taste sweet, delicious ice cream. Card C. Oh, it also tells me if something is too sour or spicy. We have 2 bugs in our tongue. The small bug and the large bug. Small bug has some tastes like sweet, sour and salty. Large bug has bitter. Now we know about tongue to taste. Let's get to the second one. Skin to touch. Card A. This is my hand. My hand helps me touch and feel. Card B. I can feel my soft cozy teddy bear. Card C. Ouch, my hand tells me a cactus is sharp so I don't get hurt. Thank you.
Okay. Can you give me an example of bitter taste? Which one is bitter?
Like
Any food, whichever is bitter.
peel of a banana.
Okay. Others? Any other?
a peel of orange.
Okay. Apart from food, anything else which is very bitter?
Okay, can you tell me why the senses are important in our body? Why we need to have a nose, a tongue?
So we could hear things, smell, and taste and see.
You have what kind of sound we have? What we can hear?
Hearing sounds.
Which are the good sound and which are the bad sound?
The bad sound is like we can't hear. And the good sound we could hear like happy musics.
Happy music. So which one is a bad one?
The bad one.
Which sound you should not hear?
Bad.
Which one? Can you give me an example of a sound which you should not hear?
If someone says bad words.
Okay, apart from that,
Hi everyone, today I'm going to present about my Alexa's raincoat test. I have 4 materials called fabric, paper and foil and plastic. First material is fabric. Oh no, my Alex is wet. Fabric is a bad material because it can absorb the water. Now let's try paper. Oh no, my Alex is wet again. Also paper is bad for a raincoat. Now let's try foil. I like the foil but it can tear easily. The last material I have is plastic. Yay, my Alex is dry. It's a good material for the raincoat. So my Alex is happy.
Hello everybody, my name is V. Today I'm going to represent my project about science. It is a game. We have to put this pin, we have to move it side from here to here without touching the wire. If we touch the wire, that means the lights will turn on, the circuit will be completed, and then that means you have made a mistake. So this is a copper wire. This is a pin attached to a blue wire connected to the hidden power inside the box that's giving the voltage. And that's how this is made, but it cannot work until we make a mistake. If we make a mistake, then it's only gonna turn on. But if we don't, that means the circuit is not complete if we do not touch the wire. So this will not turn on if you don't make a mistake.
is your switch on? Okay.
Let's try it. Do you want to play?
Yeah. How do you?
You have to start from here without touching the wire. Only get 3 tries. If you touch the wire 3 times, you lost. Only get 3 chances. Who wants to go first?
You can put it there.
Keep it there.
It's 5 times now.
Does it?
I touched. You touched it.
It does work when you touch it. Huh? There. Yeah, I did one.
But it,
You can try.
any questions?
Yeah, why it is switching on when we are touching and when we are not touching?
Because if we are not touching, the electricity cannot flow through and connect. So if this touches, then the electricity can pass through and touch the bulb to give it electricity to turn on.
Okay. But if I use a plastic, this one,
Plastic pin.
plastic pin, then what will happen?
If you use a plastic pin, it would not work. The electricity would get stuck, because metal is a good conductor, but on the other side, plastic is not a good conductor. It's a material, but not a material to let electricity flow like metal and copper. So it wouldn't work.
Okay. Can you give me an example surrounding you where conductors are working and not conductors are working? Something like that.
Like the light,
Okay. So light is, how is it working?
because
Is the glass is conducting electricity?
no,
What is it conducting?
it's conducting from an electricity source
Yeah, but through what?
through wires.
Wires.
Like the wires is the tunnel where the electricity pass through, like it's a car, but a car is passing through a tunnel, but it's the tunnel's name is a wire.
Oh.
So do you play this game at home?
Okay. And in this wire, why it is coated with plastic?
Plus
This wire is coated with plastic, isn't
it's
it?
no,
Why is it so?
it's not plastic. It is it's rubber.
Why
It's
is it with rubber?
that you don't get shocked when you touch copper.
Oh.
So what's inside to make it work?
A lot of wires and a battery.
Or battery and a lot of wires. Why do you need a lot of wires?
To connect to this, we made it more wires that it can get more electricity.
Where do you think you would find a game like this?
In the market or something, but not like this. It's a plastic, but this is another model.
This is a simpler one.
Do you think paper conducts electricity?
It's not simple. It took 7 hours to wire.
Oh.
It's not simple, it took 7 hours to wire.
Okay. And then
Yeah.
do the papers conduct electricity?
No, they do not. They are just there for showing the color.
And what about that is there anything which is conducting electricity but it is not a metal? Apart from metal,
No, there is not.
nothing which can conduct electricity.
But the copper is a type of metal.
Apart from metal, very good. Copper is a metal, but apart from metal,
There is only plastic and paper, so and a cardboard box under, so there is nothing
Do you
else.
think water conducts electricity?
No, of course not.
water can't conduct.
It can only reflect light.
Oh,
Good morning. Today I'm going to be talking about electricity. Electricity needs a source of power. In this case, the source of power is the battery. Electricity powers up our appliances. Conductors. Conductors are materials that allow electricity to flow through it. Insulators are materials that do not allow electricity to flow through it. Let's go through this material, there are conductors or insulators. Metal is a conductor. Wood is an insulator. Graphite is a conductor. Plastic is an insulator. Rubber is an insulator. And finally, fabric is an insulator.
Okay.
I think you forgot you left one.
I did that.
If graphite is an insulator, why is it not lighting up? Could you show me? Yeah, now it is.
So the graphite is a conductor, but the wood
Is an insulator.
on the pencil.
Is an insulator. This.
So the one around the pencil won't conduct.
This one will not do.
Why won't it conduct?
Because it is wood.
Any other material apart from metal which conducts electricity?
Yeah, metal.
Apart from any metal. I'm not talking about.
Copper.
Is copper a metal or not?
Yeah. It is a metal.
Yeah. So,
But this is rubber.
yeah, so it is not conducting.
Yeah.
But I'm asking, apart from any metal,
Copper.
don't talk about metal.
Granite.
Granite.
Yeah.
Is this granite? This is granite. Is it conducting electricity? So why are we not getting a shock? We are standing on granite, yeah?
Sure.
If this wire, if I cut this wire from here, do you think this would still light up?
Yeah.
If I cut the wire from here?
From here.
Yeah, if I just cut it off with scissors. Would this still light up?
Yeah.
What if I cut the wire from here?
Nope.
No. Okay, and then when you were switching on and off, yeah? Like this switch was off, right? It was not lighting. Why
Yeah.
it is so?
Because the circuit is not complete.
Okay. And apart from battery, what do we use for the source of power? What else?
A source of power.
Like all of these lights.
The wall socket.
Yeah, but is it a wall socket which is conducting, giving the energy? Or what is giving energy?
The
See, when you are putting
wire.
TV to the socket, so what is it which is conducting giving
The wires.
Wire is giving or wire is conducting? What
Wire.
is the source of energy then?
Source of energy.
Is there a battery? When
In,
you are talking about TV, lights, is the battery
yeah.
giving energy or something
where's
else?
the battery
What do you
for
call
this
apart from battery?
A source of power.
Yeah, so what is the source of power?
The battery.
What do you call it, that source of power?
The battery.
Apart from battery. Some things don't work with battery. Now he's
Don't
looking
look at your
someone.
friend.
What?
Hey, answer my question. Apart from battery, do you have everywhere batteries?
Not everywhere.
Then what are we using?
The wire.
Wire?
The switch.
Switch is only switching off and switching on. What do you call those things in the house where we get the power to washing machine, toaster?
Generator.
Thank you.
Good morning, everyone. My name is Shreyansh and this is my science project. I am going to talk about animal habitats. The title is Animal Habitats Around the World. A habitat is where animal lives. I am going to show you different habitats and which animals live there. And those habitats are aquatic habitat, forest habitat, animals that live on both land and water, desert habitat, Arctic region habitat, and aerial habitat. I am going to show you guys one by one which animals live where. I am going to start with the aquatic habitat. Some animals live in the water. For example, a blue marlin and a clownfish. Some animals live in the forest. For example, a monkey, wildebeest, and elephants. Some animals live on both land and water, which is a hippopotamus. A hippopotamus stays all day in the water and comes out of the water at night. They can kill you. They are herbivores, but they are also predators. They may look big, but they are very fast. They can run as fast as a car. There is also a frog. A frog has a life cycle, which is an egg, a tadpole with legs, froglet, and an adult frog. Frogs lay their eggs on a lily pad. Until a frog is an adult frog, they do not need any food because the tail can act as the food. There is also a desert habitat. Some animals live in the desert, like a camel. A camel needs water, but it doesn't need to drink from a pond for many days because the hump is like a hill on the camel's back that stores water for it to drink. There is also a tarantula. A tarantula is very dangerous. It is a predator and it is venomous. So be careful when you're around a tarantula. It can kill you because its sting has venom. There is also the Arctic region. Some animals live in the Arctic region, like a walrus. A walrus is a carnivore. It has big teeth like a saber-toothed tiger and it feeds on fish. It lives on ice. There is also an Arctic fox. An Arctic fox is a carnivore and its fur helps it stay warm in the cold. It is a predator. Last but not least is the aerial habitat. Some animals live in air. Like a bald eagle. A bald eagle is a predator. It feeds on fish and other small insects like worms. It has a hooked beak to rip its prey apart. There is also a cockatoo. A cockatoo also feeds on fish and other small insects like worms. It is part of the parrot family. They are usually grey or white in color. Thank you. I hope you learned more about animals and where they live.
Yeah,
Thank you.
Okay, if you took the baboon over there and you put it in the Arctic habitat, do you think it could survive?
No,
Why not?
because that's not where its food and that's not where it lives and there is no food for it
okay. Where would you put a polar bear?
in the Arctic habitat.
Why?
Because it lives there and it has food that it
But
eats.
what if it gets food in the forest as well?
But it will stay in the Arctic because it meant to stay in the Arctic, and there's also fish that it eats. Yeah.
Okay, if we provide the fish, okay, food is available, but still we are putting that in Arctic.
Arctic.
Will it survive?
The baboon. No, it won't survive. The baboon won't survive because it's too cold.
That is what we do. Okay. And then there are different kind of foxes, isn't it? One who lives in the desert and one who lives in Arctic, isn't it? Arctic
No,
fox and another fox which lives also
in the forest.
desert. Yeah.
No, there's no fox that lives in the desert.
Are you sure?
It's in the forest.
fennec fox
Yeah.
that lives in desert, and Arctic fox lives in Arctic. What is the difference between their appearance?
The phoenix fox likes the heat, so that's why it lives in the desert, and the Arctic fox likes the cold.
No, but what is the difference between both of them?
The Arctic fox has fur to make it warm, but then the fennel fox does not have fur like to make it feel warm, thick fur.
So why did you decide to do this project? Why is it important?
Because I like animals and I think it was nice.
Do you think it's important for humans to see a project like this? Why do you think we would think it's nice?
Because then you guys can learn more about animals and where they live.
Also, do you think the animals will have different bodies according to where they live?
Yeah.
How so? Can you give me an example?
Like the baboon, doesn't have fur, and it like doesn't have fur to keep it warm, and the Arctic fox does.
What about fish?
Fish?
Do they have lungs?
No, but they have gills.
Okay. So how does gills help them to live in?
The gills help them breathe in the water.
Okay. And in the hump of the camel, do they store water?
Yeah. They store water so that they can drink when they're thirsty, and there's no water
They
in the
drink.
desert.
How do they drink?
Like the hump stores water, and then the water can go to the mouth.
Just find out, do they store water or not? Find out on your own, okay? When you go home. Okay?
My name is Avlinkar. Good morning, everyone. My name is Avlinkar Bansal. I'm from class 2D, and today I'm going to present to you about electricity. Welcome to my journey of electricity. What is electricity? As electricity is energy that flows through the wire to make things work, like TVs, computers, microwaves, and fridges. Where does electricity come from? Electricity comes from a power plant. Once it is made in a power plant, it goes through the wires, then to the transformer, then to the electric pole, then reaches our home, school, and factories, like this picture here. How is electricity used in different places? Electricity is to light up our homes, cool our food, heat our food, to charge our phones and laptops, and also to print photocopies. Who invented the first electric bulb? Thomas Edison was a great inventor. He invented the first electric bulb. Here is his picture. Who is Michael Faraday? Michael Faraday discovered that electricity could move. This is his picture. Electricity needs a path to travel. It's called a circuit. Let me explain for it what we need. We need a battery, switch, wires, and a bulb. What is a battery? A battery is a man-made power cell used to store electrical energy. What is a bulb? A bulb is to shine or not to shine. What is a switch? A switch is to break or make a connection in a circuit. There are three main types of switches. One is a press switch, one is a slide switch, and one is a rocker switch. Now, what is a wire? A wire is a long thin piece of metal that carries current. Inside it, we have metal, like over here. If I take my two crocodile clips and connect it together, it starts working. Why? Because metal is a good conductor. Then we go to the other ones. It also, and this one too. So these all are metal, and if I connect it to my mini speaker, it makes sound. Why? Because the electrical energy is converting it to the sound energy. And why is the bulb lighting up? Because the copper coil is a good conductor that I have inside of my mini speaker. And here are some other materials that are called non-conductors. This is wood, cardboard, plastic, and paper. So it's a conductor is when electricity could pass through, and a non-conductor is when electricity could not pass through it. Now this is a complete circuit. When I turn on this button, it's lit up. The bulb will not light up. When is that? It's when the battery is not connected to the wires, or the switch has not been turned on, or the wires are damaged, or maybe the wire has a gap in between the circuit. But when I turn it on right now, it's a complete circuit. Why? Because all of them are connected and now it's working. Now let's go to my first model. My first model is a mini fan. The material I've used for my mini fan is a battery, wires, switch, and an electric motor, and a mini fan for my toy car. What is an electric motor? An electric motor is when electricity could. A motor is when it uses electricity. It uses electricity. It's a machine, and it makes things go round and round in everyday items such as washing machines, toy cars, and fans. Now if I turn it on, it will start working. Why? Because the battery is carrying current through the wires, and through the wires it's going to the electric motor, and the work of the electric motor is to spin this mini fan round and round. Now if I switch it off, it's not working. Why? Because it breaks the connection in this circuit. Now if I turn it on, it starts working. Why? Because now it's bringing the connection back. Now let's go to my second model. My second model is a carnival ride. The materials I've used for my carnival ride is cardboard, paper, candle, thread, toothpick, electric motor, battery, wires, 2 crocodile clips, and decorations with tape. Now if I connect these two together, they start working. Why? Because the battery is carrying current through the wires, and it's going to the electric motor over there. And now if I stop it, it will stop working. Why? When the battery is giving energy through the wires, and when we break a gap on it, it stops working. And if I connect it back together, it will start working. Why? Because it has been connected. Now isn't it interesting? Are you enjoying? Now, if in facts about carnival rides, in big carnival rides we use big motors, and in small carnival rides like this one, we use small electric motors. Because if we use these small electric motors in this big carnival ride, it will stop working because the energy is not going to be enough for the big electric motors. Now let us go to my safety rules. Why am I taking you to some safety rules? Because electricity is very dangerous, and some of the electric rules is: do not put fingers in the socket, do not put cells in fires, do not use electronics near water, do not put plugs, do not overload the plugs, and do not put wet hands next to the socket. If somebody gets a shock, what do? You get a dry wooden stick. And why are we using a dry wooden stick? Because wood is a non-conductor, and a non-conductor is when electricity could not pass through it. That's why we're using a dry wooden stick, so we can save this guy. Why? In this picture, this guy has gotten an electric shock, and this person is pulling this guy, so he couldn't get an electric shock, and that's how we saved him. Thank you. I hope you understood about electricity and learned something about electricity. Thank you. Okay.
Why are we not using electricity with water?
Because water will make electricity to get a shock when
Why we are getting shock?
because of the electricity is very dangerous, and we put water next to it, it will make a shock.
But why water?
Because
If I am putting something else, let's say wood,
yeah,
it is still not giving me shock. Why only water is giving shock?
because water is a conductor.
Good.
My name is Nia, and today I'm going to be presenting about wind electricity generation. Introduction. Wind is a renewable source of energy. In this project, I investigated how wind can be used to generate electricity. Wind turbines convert energy of moving air into electrical energy. The aim of my project is to demonstrate how real wind how to convert electricity to wind energy to electrical energy. Materials: fan blade, pulley and belt, wires, stand and base. Produce. Wind blows into the turbine blades. The blades begin to rotate. The pulley system transfers the motion to the motor. The motor acts as a generator as it produces electricity. Energy changes as wind energy to mechanical energy to electrical energy. My model showed that when the blades rotate faster, more electricity can be generated. This demonstrates how real wind turbines produce electricity. Conclusion. I conclude that wind energy can be converted to electrical energy. Wind power is an environmentally friendly, helps reduce pollution. Important: clean energy source, renewable and sustainable, helps reduce on fossils, helps protect the environment. Thank you.
So over here you're using this thing to turn the thing, but in real life we need wind. So what happens if there's not enough wind?
If there is not enough wind, this light will not light up that much. It will not light up bright, so it will be dim.
Is there any other renewable energy source apart from wind? We can generate electricity.
No.
We don't have any other than wind.
No. No, we don't.
Okay. Okay, when this fan is working, right?
Yeah.
So you said that electric energy is converted to?
Wind energy is converted to electrical energy.
Okay. So can you give me an example what we are using at home where same movement can happen, where electricity is converted to movement? Any electrical appliance which we are using,
Yeah.
so because of electricity, it moves and gives you, it moves. It converts into movement.
It's because the wires, they like, there's some wires that connect to, what do you call it, to our house, and that, so like there's some kind of wires that they connect everywhere inside the house, so that when like we on the switch, so it like, example, it is connected, the house is connected to the wind, the turbine, so it will go all the way, this will start to rotate, and then the wires will take it all the way to the switch, and then it will take it all the way to the switch, and then it will go to the light.
Okay, this is a small one. So to do it in real life, would you need more, or this would be enough?
We would need more.
We need more.
Have you seen the windmill anywhere? Where did you see?
I saw in Gong Hill.
Huh?
Gong Hill.
Wrong Hill. If we were in Gong Hills right now, do you think the blades for the turning would be here or over here?
The blades,
Yeah, for turning it with the wind.
it would be here. No, it would be
The blades to make the electricity come. Where do you think the blades would be?
it should be here.
So do you think the amount of electricity that's made would be affected by how much wind there is that day?
It depends how much wind power there is.
So if there's less wind, would you expect more electricity or less to be generated?
Less.
Okay, thank you.
Come.
Morning, my name is Diana Savla from class 2F. Today I'll be presenting to you a topic called environment and habitats. What is the environment? What is the environment? An environment is everything around us, including air, plants, people, and more.
What is an habitat? An habitat is a specific home inside the environment where a plant or animal lives, finds food, and stays safe. Living and non-living things. In the environment, they are both living and non-living things. Living things include plants, animals, and people. Non-living things include rock, plastic, sunlight, and rain. Habitat, the perfect home. Every animal and plant has a special home or habitat that gives them exactly what they need. Every habitat provides the four main things: food to eat, water to drink, shelter to stay safe from danger, and space to move and grow. Different types of habitats. Since our world is so big, there are many different types of habitats that includes forests and woodlands, oceans, deserts, grasslands, freshwater habitats, and more. Now let me explain you the three main different types of habitats that I have made. 1. Grasslands. Grasslands are wide open spaces filled with mostly grass and very few trees. Some many amazing animals like deers, tigers, cheetahs, elephants, and more. Did you know grasslands provide food and shelter for some of the most awesome animals on our earth?
Like which ones?
Like tigers, turtles, and more. Second, ocean habitats. It's a giant water world. The ocean is a huge, massive home made of salty water filled with fish, whales, and more animals. Also, there is a beautiful coral reef where fishes love to hide and play. Lastly, snowland habitat, also known as the Arctic or polar region, and is a freezing ecosystem covered in snow and ice most of the year. We find adapted wildlife like polar bears, penguins, viper snakes, walruses, seals, fishes, and more live in this region. I hope you enjoyed this presentation about environment and habitat. Thank you.
So, which other animals live in the Arctic region other than what you put? You know any others?
Like they are viper snakes which like to hide in snow, walruses, and some more.
And why can't the polar bear survive in the jungle?
Because polar bears have white fur which blends into the snowland habitat, and polar bears don't like to be in the jungle. They like a place where it's cold, like in the Arctic.
How do you think the body of a polar bear would be different from the body of a tiger?
The polar bear has fur and is like it's cold, and tigers, they have orange and black fur, and tigers are wild animals.
Polar bears are not wild animals.
They are wild animals, but not wild like lions and tigers.
Which one of the two would have more fat in their body?
The polar bear.
When they are hunting, what do they have which helps them to hunt? the polar bears?
The polar bears have
What is in their body that helps them hunting for food?
there is
And how do these fish breathe?
fishes like this. They go in the water, and then when they have some nostrils which if they like want to breathe, they go in the water, they stay, and then they like look, or they only put their eyes with a little bit of their this much part, and then they put it up, and then they go down
They
again.
breathe through nostrils.
Yeah.
Why do you think it's important for us to know about this, about the animals?
So that like other people or you guys can visit if you like.
Any other reasons?
Not really.
What will happen if we cut down all the trees? Like humans, generally they do cut down the trees in the forest.
Like if you cut a tree, you won't have much oxygen because trees provide oxygen.
What else will affect these animals?
The animals will not have places to like hide and play and do things they want.
Okay, Myra.
Good morning. Good morning. My name is Mara Call from class 3A, and today I'm going to present about light and shadow. What is light? Light is a form of energy that helps us to see everything around us. The sun is the biggest natural source of light. Can you guess any other sources of light?
Light bulbs.
Yes. Now let's talk about shadows. What is a shadow? A shadow is a dark shape created when an opaque object blocks light. Some facts about shadows are that they are dark, they have no color like the real object, they can become bigger or smaller depending where the light is. And did you know that solar and lunar eclipse are also only a shadow? A solar eclipse happens when the moon gets in between the sun and the earth. This creates a shadow to fall on certain portions of the earth. And a lunar eclipse happens when the earth gets in between the sun and the moon, which creates a big shadow to fall on the moon. Now to explain all of this, I would like to tell you a fun story about how shadows work. Once in a jungle there was a small rabbit and a big lion. One day the little rabbit was hopping around looking for carrots. Then the lion came and said, "Today you will be my dinner." The rabbit got scared and wondered, how can I escape the lion? Then the rabbit thought that it can use science to save itself. The little rabbit picked up a carrot and turned to the lion and said, "Mr. Lion, I have a magical juicy carrot which can turn me into a huge monster." The lion laughed and said, "Prove it." The little rabbit went behind a bush, took out a torch, and stood very close to it. This created a big shadow of the rabbit, and the lion got scared and ran away. That's how the rabbit saved its life using science. Thank you.
Which natural light sources do you know about?
The sun, fire, stars, a firefly.
What about the moon? That also gives light.
The moon reflects the light of the sun.
And what about other stars?
Do the stars reflect light or do they have own light?
They have own light.
And what about planets?
The planets don't produce light.
So why does when you move your object away from the light, why does it become bigger and smaller?
Because if the object is closer to the light, its shadows becomes bigger. Cause when it gets closer to it, it's blocking more light, so the shadow becomes bigger.
Do you think scientists use this knowledge anywhere else other than eclipse for shadows?
How is your shadow in the morning?
Early morning, it's long, but then because the sun is low, and when it's 12, the sun comes right above us, so our shadow becomes very short.
Like in the olden times, they used shadows for something. Do you know?
To tell the time,
What's the device called?
a sundial.
If I make this lion and rabbit with a glass,
It won't have any shadow because it's transparent.
Have you ever wondered why a toy car zooms across a smooth floor but stops quickly on a carpet? Or why we can walk without slipping every time we take a step? The answer is friction, a force that affects movement every day. My name is Priva Gandhi, and today I'm excited to present my science project on how force and friction affect movement. A force is a push or a pull. Friction is also a force, but it slows things down. For my investigation, I used a toy car to see how different surfaces affect movement. Now I'm going to start my project. I'm going to have to put the ramp on the floor. First, we're going to start with the foam. Next, we're going to measure the bubble wrap. Then we're going to do sandpaper. Then we're going to move to single-faced craft paper. And lastly, we are going to do aluminium foil. Now, to measure accurately, I'm going to put sellotape at the back of the ramp so I could measure. Let's first measure how much the foam was. The foam was 94 centimeters. Next, we're going to measure the bubble wrap. For the bubble wrap didn't come off the ramp, so we can just measure from here. And it moved 7 centimeters. Now we're going to measure the sandpaper. The sandpaper was 127. Then we're going to do the single-faced craft paper. The single-faced craft paper was 99 centimeters. And lastly, we're going to measure the aluminium foil. The aluminium foil was also 94 centimeters. By the end of my project, we've all learned that smoother surfaces create less friction, so the smooth surfaces allowed the car to move further because they create less friction. But the rougher surfaces created more friction, so the car wasn't able to move as far as the smooth ones. Thank you.
So what have you changed and what have you kept the same in this investigation?
We've changed the different surfaces and how far the car went. We kept the measuring tape the same, the tape, how much force I used, and the same toy car.
So what are your results?
My results are the bubble wrap went the least away from the ramp, and the sandpaper went the furthest.
So, and your conclusion is?
My conclusion is that smoother surfaces create less friction, so objects can move further, while rougher surfaces create more friction, so objects can not move as far.
Apart from this friction, What else can affect the movement of the car?
How much force I use.
Okay. Will the height of the ramp will affect?
Yes.
How will it affect if you use a higher ramp?
If you use a higher ramp, the car will move farther because it's more away from the ground.
Why is it so? That when it is higher, it reaches further.
As you can see, this ramp is not as tall, so it's near to the ground, so it will move a little far. But if you keep the ramp up, it will move further because
What is the reason?
because it
Can you tell me where you use this? Why is this important in real life?
This is important so you could see how you can walk without slipping, and how when you ride a bicycle and you put brakes, the bicycle stops. And if there was no friction, cars would just be we would be slipping every time we walk, and cars would be changing direction every time.
How did you make your test fair?
I use the same height, I use the same car, and I use the same strength.
Do you think there could be any sources of error for results? Like anything that could have made your results wrong?
No. Here
Is always
Here some results. I gave some questionnaires to my class, and this is how they answered.
Tell me, is always friction helpful?
Sometimes it's not, and sometimes it is.
Can you give us the examples where friction is not helpful, but it is harmful?
When friction is helpful when we are walking, because if there was no friction we would slip, and friction is not helpful because if there was too much friction we wouldn't be able to walk smoothly.
Any other where it is harmful?
For example, if there was no friction at all, cars would not be able to move straight and smoothly. We need enough friction for enough things. Like when we are walking, we don't need too much friction, and we don't need.
You can.
Did you see that? Was that magic? No, it was science. There are many invisible powers all around us. We cannot see them, but they always work. A force is a push or a pull. Because I like playing football, I'm going to show you how force works. Force can start moving things, stop moving things, speed up objects and slow down objects and change direction. Go. Force can bend things, stretch things, squeeze things, flatten things, and also tear things. Friction makes things go slow. I'm going to test my toy car on a rough road and smooth road. Rough road, more friction. Smooth road, less friction. In our everyday life, we use slides, bicycle, and walking. Too much friction could be harmful. The machines breaking, the shoes tearing, and also tires popping. Friction is also important in sports. I wonder how I can play with a basketball, with a football, and a football with a basketball. They're both balls. So a football is a smooth surface. It goes very fast on the ground, but a basketball is a rough surface. That means more friction, so it doesn't slip off your hands. You see these rackets and you see the belt, they're called grips. Grip is to help you hold it, and when you swing, it doesn't slip off your hand. And you see the shoes I'm wearing, they're called studs. Studs are meant to be played on the ground, and when you're running, you don't slip. Our next force we are going is to magnetic force. Magnetic force attracts to magnetic material. You see those big machines in the factory? They separate magnetic material. And you see the big machines in the MRI machine? They help the doctor to scan the person's body. Our next force is going to be gravity. Gravity pulls everything to the center of the earth. Why is gravity important? It helps us walk, move, keeps us on the ground, and makes things fall down. Let me tell you a fun fact. If you want to lose weight, you go to space, and space has less gravity, so you weigh less. But over here, you weigh more. Let me tell you a scientific inquiry. I wonder how boats, ships, and birds fly. So I did a research. You see these two wings? The wings pushes the air down. The air gets angry and pushes the plane up. That's called lift. Lift is stronger than gravity. That's why it makes the plane fly. If lift was weaker than gravity, the plane could have fallen down. I wonder how. I wonder how boats float. If when I threw this stone, it sank. But when I put this boat, it floated, because that's called buoyancy. Buoyancy is stronger than gravity. That's why the
Don't touch.
rock sank. But if buoyancy was weaker than gravity, the boat could have sank. So when I went to Egypt, I sat on a hot air balloon and I wondered how it flies. So I put hot water and tested it. So the cold air is heavier than the hot air. That makes the balloon fly. So I hope you have learned something new, and I've done so many researches about force, friction, magnetic force, and gravity. Thank you.
Do you think weight and mass is the same thing?
Yes.
How many kilograms do you? Yeah.
I weigh 20.
20 kilograms. So, is it your weight or
Or
is
your
it your
mass?
mass?
My weight.
in this experiment, can you tell me what you were trying to investigate?
I was trying to investigate how the boat floated, and the rock sank, and how the hot air balloon managed to fly.
So why did the boat float and the rock sink?
The boat floated because buoyancy was stronger, but if buoyancy was weaker, it could have sank both of them.
Is it a fair test, Yoga? What do you mean by fair test?
Fair test? No, I did a research.
You did research.
My name is Urafsha from class 3D, and today I'll be presenting about the magic of light and shadows. Let's begin with, what is light? Light is the form of energy that helps us see the world around us. There are many sources of light, some natural like the sun and stars, some man-made like our phones and torches. There are also many properties of light, like light travels in straight lines, and when it's blocked it makes a shadow. Light can be reflected. When you shine a torch in a mirror, the light will bounce back to you, and light helps us see. And light can pass through some materials, like transparent materials like glass allow all the light to pass through. Here, this torch will be my light source, and this magnifying glass will be my transparent material. All the light is passing through. That means it's a transparent material. Translucent materials like tracing paper allow some light to pass through. And opaque materials like wood don't allow any light to pass through. Let's move on to, what are shadows? Shadows are dark shapes that form when light is blocked. Shadows are impacted by the material of the object. Like I've already told you, the distance between the object and the light source, the angle of the light, the shape and size of the object, and the brightness of the light. You can have fun with shadows with your hands, like I've put here. You can also have fun with shadows outside. Now, we've reached the fun part of my project, my scientific investigation. My aim is to find out whether the distance the object is from the light source affects the shadow. My prediction is, the closer the object is to the light source, the bigger the shadow. I've put a diagram here to explain my prediction. The ball which is closer to the torch is making a bigger shadow than the one than the below torch, because it's blocking more rays of light. To test this out myself, we will use this box to make the shadows of this tree man. I've tried this a couple of times at home, as you can see, but I'll try it once here. Let's start with 45 centimeters away from the light source. It's approximately 5 centimeters. Let's move it to 30 centimeters away from the light source. As you can see, the shadow is already bigger, but we're still going to measure it. It's approximately 8 centimeters. And now let's move it really near to the light source, 15 centimeters. As you can see, the shadow is now humongous, but we're still going to measure it. It's 15 centimeters. That's as big as my ruler. As you can see, my prediction was correct. The closer the object is to the light source, the bigger the shadow. The controlled variables of my investigation were the same torch and brightness of light, the same small toy, the same box, and the same unit of measurement. The independent variable was the distance of the object from the light source, and the dependent variable was the size of the shadow at different distances from the light source. Let's move on to light and shadows in daily life. We use light and shadows in our lives so much that they fit in subconsciously without even knowing. In ancient Egyptian times, Egyptians relied on sundials to tell time. Sundials worked because a stick in the middle put a shadow on a number, helping Egyptians to tell time. Photography and cinematography. This is a form of light and shadows we use to entertain us. Next, a very basic but important way of using shadows. Shade. This table on a sunny day is getting some shade with some bushes hanging on the roof. Next, X-ray. This is an X-ray of my very own tooth when I went to the dentist. When light is thrown in my mouth, all the objects such as my teeth, my tongue, and my gums that block the light were put into this picture. And my teeth are white, unlike my tongue and gums, because they reflect more light. Next, senses. This is me walking into a lift at my house. The lift door didn't close on me because I blocked the lift's light lasers, making the lift door stay open. Same with barriers for cars. When the car blocks the barrier's laser lights, the barrier stays open or opens. And these are just some of the uses of lights and shadows in daily life, as there are many more. Thank you.
Very good presentation. Okay, how do you think as you can see, when you go further, the shadow gets a bit, the shape distorts a bit. How do you think you could improve that in your experiment? What changes could you make?
I could have brought a digital ruler to make the measurements more exact.
And do you think there are any sources of error when you're measuring the length of the...
No.
How do you make your test reliable?
By doing it more times.
What did you do to make sure this is a fair test?
Use only one variable, which is the object's distance from the light source.
Would this other light affect this?
It would only affect when the object is near to the torch, because the surrounding light would make it unclear.
Everybody, my name is Nema Maya and I'm from class 3E. Today I'll be presenting my hydraulic robotic arm. My topics are forces and magnets. My objective was to show how forces move the hydraulic robot arm. Have you ever seen a car being lifted easily at a service station, or notice how cranes carry loads? Well, the amazing work is done by her hydraulic robot arm. My inspiration: when I was going to Sarit Center, I saw construction workers carrying heavy objects, so it inspired me to make the hydraulic robotic arm. How it works: when you push a syringe, you apply force. The water transfers this force. The force causes the robotic arm to move, lift, push, or pull objects. Uses: it can sort out trash, it can sort magnetic and non-magnetic materials, it can lift heavy construction materials. Why it uses syringes? To create the force of water to power the hydraulic robotic arm. As you can see, when I push the orange syringe, when I push the orange syringe, when I push the red syringe, it will go down, and when I pull it, it will go up. The green syringe makes makes it open its handle and close it. Thank you.
Could you show this, demonstrate a bit more?
Okay.
You can do it again. And you can also explain.
When I push the orange one, it will go up. When I push the red one, it will go down. And when I push the green one, it will open these things a little bit more.
What is the principle of science you have used here?
I've used the hydraulic robot arm.
Hydraulic robot arm, but how does it work? Principle of science.
When I push a syringe, the power of water will transfer to my robot arm and make it move.
How is it useful in our life?
If it was metal, it could carry cars, help construction workers when doing their work, and it can grab things and put them anywhere.
One day, I noticed something interesting when I shone a torch on a toy. It made a shadow. Then I wondered, what is a shadow and can light make different colors? So I decided to investigate how light works, how shadows are formed, and how red, green, and blue light mix to make new colors. Hello, my name is Ciara Haria from class 3F. Please learn and enjoy my presentation. What is light? Light is a source of energy that helps us to see things. Without light, everything would be dark. Light travels in a straight line. Did you know nothing is faster than light? Do you know the speed of light? It is 300,000 kilometers per second and 3 times 10 to the power 8 meters per second. And because of that, the light from the sun reaches us in 8 minutes and 20 seconds, and that from the moon in 1.3 seconds. What is a shadow? A shadow is formed when an opaque object blocks light. Now I will demonstrate. I am shining a torch on a white background. If I put a pen in between, it forms a shadow. If I move the pen closer towards the light source, the shadow becomes bigger and blurrier. If I move it away from the light source, the shadow becomes smaller and sharper. Let's just see what happens when I place a slit in between the light source and the white background. It forms a thin straight beam of light on the white background. This shows that the light travels in a straight line. Do you know the 3 primary colors of light? They are red, green, and blue. Let us see what happens when all 3 lights are shown at the same spot. Isn't this amazing? It forms a white light. If I switch off the green light, it forms a magenta color. If I switch off the red light, it forms a cyan color. And if I switch off the blue light, it makes a yellow color. This is called additive color mixing. We have special cells in our eyes called cones that sense red, green, and blue color. When both the cones are activated, our brain sees a different color. Now, I am going to place a slit in between the light source and the white background.
First, they mix to make white light, and now they are separated. Blue is on this side, red is on this side, and green is on this side. This shows that light travels in a straight line again. Now, let us see what happens if I place an object in between the light source and the white background. I am placing a pen in between the light source and the white background. Look, it makes 3 colorful shadows. Yellow is formed because the pen is blocking the blue light from going onto the white background, and it's due to a mix of the red and green light. Cyan is formed because the pen is blocking the red light from going onto the white background, and it's due to a mix of the blue and green light. And likewise, magenta is formed because the pen is blocking the green light from going onto the white background, and it's due to a mix of the red and blue light. Now, I am going to take all 3 colored shadows through the slit. I am going to put magenta through. It blocks the green light, and the green light is going in a straight line. Now I am going to place the cyan color through. It blocks the red light, and the red light is going in a straight line. And likewise, if I put the yellow color through the slit, it blocks the blue light, and the blue light is going in a straight line. All this shows that light travels in a straight line. So far, we've learned that light mixes to make new colors. The object blocks some light but not others. Here are some real-life uses of light, shadows, and color mixing. Light enables us to see things, televisions, phone screens, and computer screens, to show colorful images, photography and film, to make images brighter and more colorful, traffic signal lights to say stop and go, and finally projectors to show images on the wall and board. I hope you enjoyed my presentation. Thank you for listening to me so patiently. Do you have any questions?
What were you investigating?
I was investigating if light travels in a straight line, how shadows are formed, and how the 3 primary colors of light mix to make new colors and new colorful shadows.
Which investigation out of these 3 did you make a fair test? Was it a fair test or only a demonstration?
A fair test.
Fair test. So how did you make it fair?
By making the torch light show the same amount of light.
Like this color one, mixing of colors. How did you make your test?
They're all the 3 primary colors of light. They're all shown at the same spot.
What's different between the torches?
The colors.
And how this one. Light travels in a straight line.
Yeah.
How did you prove it?
By shining this torch through the slit, and it's going on the white background.